Okay, so now I'd like to talk a little bit about how we actually measure color and how we define color spectrum. We've talked in terms of hue and saturation, but those are very sort of nebulous. Those scientific people want a better way of defining color. And as LEDs are evolving, defining color and color properties is becoming increasingly important so that you understand what fixture you're buying. So one of the earliest ways of doing this was with something called a color rendering index, or CRI, right? And every LED fixture has different properties. And the color rendering index is a method of measuring color quality. You'll see at a CRI here is a rainbow colored fruit. I don't know what that would be, but at a color rendering index of 50, the fixture does not produce very complex wavelengths and therefore is not able to produce the vibrancy of this color. As we move up to a color rendering index of 80, you'll see that we actually start to reveal more accurately this color, this rainbow color. And as we move to 95 or greater, that the colors really become vibrant. So that's color rendering index. Color rendering index is used based on sample of 15 colors to score the color quality. So these are the colors that it is measuring, a range of colors, and it's measuring how well a fixture can produce these individual colors and how accurately they are. And here are the color samples as they go around. So 15 color samples. Now let's look at color rendering, right? All of these sources are at 2700 degrees K, right? And an apple at a color rendering index of 97 as we move to 90, 80, and 70. And you can see how this measurement of color accuracy, right, affects how we perceive an individual or a specific object or a specific color. Okay, the manufacturers very quickly learned how to game this system. And that with only 15 colors, they tried to make sure that their emitters were good at any one of these individual frequencies. Not that there were 15 of them, but that they overlapped and that they blended together. But the net result was that there were still voids and inaccuracies. They really did try and figure out a way to kind of cheat the system to get their CRI numbers high, right, nearer the 95, 97 range, so that they would, so you would believe that their fixture was really good. So in answer to that, there was developed TM30-15, which just stands for Technical Memorandum 30-15. And in this system, there are 99 different color samples. And a lighting fixture then is measuring across 99 different color samples and how well it's able to reproduce those colors, right? So let's look at it in action, right? So if we look at desaturated versus enhanced, TM30 is represented as a graph. And it's typically in reference to its red and green properties, right? And how accurately it produces those and how completely it fills in that spectrum. So you'll look in this is a lower TM30 value, especially on the red and the green, that's not able to fully fill in these colors. And this is what our result is. Something that's reaching pretty high into that, right, where we're filling in the red factor and the green factor pretty well, right, through this. This is fairly neutral in a TM30. And then if we were to move towards enhanced, to where we're actually pushing more green spectrum and more red spectrum than what would be neutral. So you have desaturated, nominal, and enhanced in TM30, which is better used to describe how color reacts. And this is not a great slide, so it's a little hard to see. But you could see in our original, you can see the red tones that are embedded inside of this, the red that is surrounding this, the red in the painting, the red in the bricks, how this in its original is able to show reds and greens As we desaturate that and pull in specifically from the red, you can see how the red, all of the red in this image is now diminished. And when we enhance, when we expand upon the color spectrum, how it really starts to push those colors and pull those colors out. So that's a little bit about measuring color and TM30.